This video is about box and whisker plots, part 1. Hopefully I'll get to do a part 2. Pre-Algebra Advanced Class, Chapter 8, Section 2. And my name is Mr. Funk, and this is March 1st, 2013. Alright, the objective is students will be able to identify points on a box and whisker plot and create their own plots. The state standard is the MA8 S31. You can look that up. Vocabulary. Now, for my students, this is going to serve as your you-dos for the class year. Just pause the video, write down the vocabulary. Welcome back. Box and whisker plot is a graph that summarizes a data set along a number line. Quartiles are numbers that divide data into 4. That's 4 even parts. 4 quarters to $1, 4 parts, quartiles. Hopefully we can make that connection there. Lower quartiles, the median or middle of the lower half of the data set. The upper quartile is the median or middle of the upper half of the set of data. Range is the difference between the greatest number and the smallest number. Interquartile is the difference between the upper quartile and lower quartile. Range, difference. Both of them are a difference. The range itself is the range of all the numbers. The interquartile range is the range from the upper and the lower. Outlier. Outliers data that are more than 1.5 times the interquartile range beyond either quartile. So if you multiply this value by 1.5 and add it to the upper quartile, anything above that value is an outlier. If you subtract it from the lower quartile, anything below that is an outlier. What's needed to construct a box and whisker plot? You need to have 5, that's right, 5 points to construct a box and whisker plot. The first thing, the values you need are the least value, the greatest value, the median or middle number, the lower quartile, median of the lower values, upper quartile, median of the upper values there. These are only 5 points you need to create a box and whisker plot. Yes, other points may be needed for certain parts of data, but we're not going to go into that in part 1. All right, the data. Here we have some data. Math test scores. We have 80, 75, 90, 95, 65, 65, 80, 85, 70, and 100. First thing we need to do when creating a box and whisker plot is find the median. And the first thing when doing to find the median is put the numbers in order from least to greatest. Now I find that after doing that, it helps to count the number of numbers. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should have 10 in my renumbered ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If they didn't match, I missed a number. I better go back and double check. But I didn't, so I'm good. All right, so now we find the middle number. To do that, we cross off 1 from each side. Bam. Cross off another one from each side. Bam. Cross off another one from each side. Bam. Cross off another one. And now we're left with these 2 numbers in the middle. Anytime you have an even number of numbers in a data set, you're going to end up with 2 numbers in the middle. When that happens, you need to find the average. Well, now, the average of 80 and 80 is going to be 80. Well, if you didn't know that, you would take those 2 numbers, add them together, divide by 2. That's finding the average. So we do that and we get an answer of 80. So the median is 80. Now we need to find the median of the lower half of the data. To find the median of the lower half of the data, we take those last 5, the lower 5 numbers. The lower half of the numbers. 10 numbers, half of it would be 5. Starting from the median and heading back, starting from the median and heading forward for the upper part. Now, when you've got an even set of numbers, you are going to include those 2 middle ones, one with the lower part, one with the upper part. If you do not have an even number, you are not going to include the median when calculating the lower quartile and upper quartile. All right, so here we have these 5 numbers. You strike off 1 from each side, bam, bam. We're left with 70. 70 is your lower half, the median of your lower half, which is your lower quartile. Finally, find the median of the upper half. To find the median of the upper half, we take that upper half of data, bring it down here. We're going to cross off 1 from each side, bam, bam. We're left with 90. So 90 is the upper quartile, or the median of the upper half of the data. We're going to take those 3 numbers and we're going to create the box and whisker plot with the highest and lowest values, starting with a number line. You need to draw a number line with a ruler, make a nice straight edge. It could start with the lowest number and end with the highest number, or you could work with some other stuff in between. Our lowest number happens to be 65, so we start with 65. and 100 for the maximum there. We put points just above the number line on that. Then we put points for the lower quartile, which is 70, upper quartile, which is 90, and the median, which is 80. We've got our 5 points. Once we have 5 points, we draw the box and whiskers on it. The box is going to box in the 3 middle points. The whiskers are going to stretch out to reach those max and mins. So we draw a line. This is the way I like to do this. I like to have one line going through each of those 5 points like that. Then I draw a box around these. You must have this line for the median. A lot of people, when they draw box and whisker plots, forget about the line in the middle. They remember to do a box here, they remember to do the whiskers, but they forget about that line in the middle. The line in the middle is the median. It's a very important number. It's part of what you look at a box and whisker plot for. All right. We should be able to answer questions based on a box and whisker plot. And here's a box and whisker plot, and we're asked, what is the median weight? Well, to find the median weight, as I said, that line in the middle is very important. It tells us what the median is. We look down onto the number line. We see that it's a second mark here, so it's 75, 76, 77. So the median weight is 77. What is the lower quartile? Well, we know that that's the upper, this is the lowest. So this is the lower quartile. Bringing this line down, we see that that is 70. The upper quartile. Now this one, in this particular graph, is a little tricky. When you look at the upper quartile here, you bring the line down. If you could zoom in on the video there, you'll see that it falls in between the 83 and the 84. So we're going to call it 83.5. And that could happen. The line could end up being somewhere in the middle there. What is the greatest weight? The greatest weight is going to be this maximum out here, which if you follow the line down ends up being on 98. What is the smallest weight, or least? This one here, which happens to be 59. Drain the line down, you see it ends up right on the 59 there. What is the range of weights? Well, the range is going to be the max minus the min, which would be 98 minus 59. So your range is 39. What is the interquartile range of weights? Well, the interquartile range is the difference between the max and the difference between difference between the upper quartile and the lower quartile, which we figured out earlier was 83.5 and 70. Subtract, and you get 13.5. Are there any outliers? Now, this is where it gets a little tricky. This particular graph is not showing outliers properly. And we're going to see that in a moment. If you do have an outlier on a graph, you should put an asterisk. Instead of this line out here, there should be an asterisk there for a maximum that is an outlier. An asterisk out here for a minimum that would be an outlier. But they didn't do that here, and I'm going to show you why. Let's take a look. If we take the interquartile range and we add it to the 83.5, we get 97. We know that this is at 98. Which means there actually is an outlier, at least one outlier out here at the 98 mark there. There should be an asterisk here instead of this line, and this line should be back with the second highest number. We're going to get into that more with a second video. The minimum, the lowest value there, if we take the lower quartile, subtract the interquartile range from it, we get 56.5, which is less than this number here. So there are no outliers in the lower extremes, but there is an outlier in the maximum. All right, I want you to take a moment to make a box and whisker plot. Remember to use a ruler to help you out. I have actually included the numbers for the minimum, lower quartile, median, upper quartile, and maximum. Take a moment. Your box and whisker plot should look a little bit like this. See you in class.